Hey there, welcome back. So in the last video we saw the right view of binary tree. So in this video we'll see the bottom view of binary tree. So here bottom view is nothing but the user viewpoint is from bottom of the tree. So if he's viewing from that angle, so what are the nodes that is visible to him, we should print that. Okay, so let's take an example as usual. Okay, let me write one example. Okay, that is okay, 1. Okay, and this is 2 and 3, and again this will move to 4, 5, and this 6. Okay, 7, and then move to this 8, and then this one to 9. Okay, so yeah, so let's take this as an example. So now the output for this tree, if the user is trying to look from this angle, okay, so that is from bottom angle, like this is the view that he will be trying to see. So for him, if he sees in this angle, the nodes that will be visible for him would be this 4, okay, and 8 and 6 and 9 and 7. So usually the output should be 4, 8, 6, 9, 7. Okay, fine. So here you might say, okay, for him there is a visibility of 5 and 6, but why did we write the 6? Okay, so if this is the case, okay, in these cases, so which is the latest node that was visible for him, we should print that. Okay, that is the condition, that is why we printed here 6. Okay, fine. So understood the problem statement, right? So given a tree, we should print the bottom view of a tree. So how are we going to accomplish this? Okay, and now here the main thing that we should keep thing in mind is, obviously for view different angles of a tree, the traversal would be level order traversal for sure. And but only thing is, what is it that we should remember at each node we are at? So if you see, we should so I'll directly explain the logic here. So we should keep track of the vertical axis of each node, kind of a line. Okay, so let's say that let's take let me draw the 5 lines here. Okay, something like this. This is assuming this is one line at which this node is. Okay, and this is also one line at which this node is also at. Okay, and this is one line at which these nodes are at, and this is one line at which these nodes are at. Okay, so if we keep track of the node with which line it is associated with, we would be able to print the nodes that we wanted. So how are we going to assign numbers to the line? Okay, so that is like, initially for line the root node we are at, we will assign it as a 0. So for every left child that we are trying to explore, we will decrement the line number by 1. That is, so here we'll decrement by 1, so this line number will become -1. And for every right child we are exploring, we'll increment the line number by 1, so that is +1. This becomes say 1. Okay, and again, so left child we decrement by line number by 1, so this becomes -2. And here we're traversing towards right direction, so we'll increment this by 1, so this 5 will again will be associated with the line number 0. Similarly, this we will decrement this since we are exploring the left child of 5, we will decrement by 1, so this is again associated with the line -1. The same way we increment wherever we go towards right direction line number by 1, and if it's the left, we'll decrement by 1. The same thing happens. Okay, so this is how, if we keep on decrementing the line numbers by -1 and +1, as we keep on exploring the left and right child respectively, we will know the line numbers. Okay, fine. Now we know the line numbers with which the node is associated with. Now we will be uh, in a good position to print the node value at each line. Okay, fine. The exploring the traversal part is fine. how are we going to store in the form of a code? So how are we going to structurize this? Good. So that is the question, that to store a node value, what we do, we will take a pair. So pair, what pair is, what we'll keep in that is the node value, okay, the node kind of, and the line with which it is associated with, okay. And since we wanted to print the values in sorted order, the best way, the data structure that we could think of when it's a tree kind of thing, like red black tree, so that is map. So behind the scenes, the implementation is red black tree, so that will be storing the values in the sorted order of the key value, okay, here. So that is what I'm talking about is map, okay. This one here, the key value we will keep is the line number, and int is the node value, okay. So that when we are done traversing, I mean level order traversal of this tree, if we print the values of this map, that would be our required answer, okay. So let me do the dry run of this. This is level order traversal, so we'll take a queue first. I told queue we will have of pair of node and int, okay. That is pair node value, and int is for the line number. So initially the queue is empty, so first we will push the root node, that is 1 comma 0. So that is the one, so we take the front value, so node value is 1, and line number is 0, okay. And then what we do, we will take the, so let's say for this example I'm just this is -2 or -1 0 1 and 2, okay. So for this example I'm assuming this is like map. I'm just, this will not be the way it will be stored in our memory, just I'm explaining, I'm drawing this for better explanation, okay. So line number here is a 0 and the value is 1. So here what we'll do, here we will store the, for 0th line the associated value is 1, okay. So fine, so now we will check for the left child and right child of this root node 1. Is there a left child and right child? Yes. So now the queue will become like this. So we pop out that above 1 comma 0. So now the queue will become, the first we'll push the left child of it, left child is 2 and line number was 0, so we'll decrement by 1 if it's left direction, and now we will push the right child of it, right child is 3 and line number was 0, will increment by 1 if it's right direction, okay. So that was done. Now the front value is 2 and 1, 2 1 minus 1, so this is node value and this is line number. So we will again for this line number 1 I will store this value 2, and again check for the left and right child of the 2. Left and right child, yes, there is left child 4 and right child 5, so we will push that. So the queue becomes like this, that is this 2 will be popped out, so here it will be 3 1, and the left child of 2 is 4, so 4, the line number was -1, so we decrement again by -1, so it becomes -2, okay. And now after right child is 5, so 5 and line number was -1, so we increment by 1, so it becomes 0, okay. So this is how the queue looks like after this. Now we'll take again the front part, so node value is 3 and line number is 1, okay. So we will store that in the map again. So for line number 1 we'll store 3, okay, and this will be popped out again. So after this the queue looks like this, that is 4 -2 and 5 and 0, okay. So now we will explore this node 4 and -2. The node value here is 4 and this is -2. If there is a left and right child for this, we will push it, or else no. Is there a left child for this? No. And first we will store for -2, the value associated with it is 4, so there is no left and right child, so we will not push anything. So after this just we'll pop this out and the queue would look like this, that is 5 and 0, okay. So this is how the queue looks like, and now the node value is 5 and the level is 0. Now this we would override this 1 with 5, that is this is how it will be we will be storing in the map. Now we'll check for the left and right child of 5. So left and right child, is there a left child for this? Yes, 8. And is there a right child for it? Yes, 9. So we'll push both of them. So that is, after this the queue looks like this. That is, line number was 0, we are going for the left, so this becomes -1. And the right child is 9, so this becomes 1. Okay, say line number. So this is how the queue looks like after exploring the child of the 5, 8 and -1. Now we'll take the front part again, that is node value is 8 and line number is -1. So again -1, we will replace whatever the value is there with the latest thing which we have explored, that is 8. And we'll check for the left and right child of 8. Is there a left child and right child of 8? No, so we'll not push anything into the queue. The queue would be like this now. Okay, that is, it will be having 9 and 1. Now we will take the front, that is 9 and 1, and now node value is 9 and line number is 1. So again whatever the value is there for line number 1, we will replace that with the 9. Okay, so this is how it happens. Again we'll check for the left and right child of root node 9. Is there a left and right child? There is none. Is there a them is something, I guess so. There is no left and right child, so okay. Here I missed the some part here. Okay, I forgot to push for this one. Once when we popped out 3 node, we didn't push the left and right child of it. So left and right child was this. What was this? Left was 6. So if we are going towards left direction, this would become 0, and also the right child was 7. Okay, that is 7, and we will increment level by line number by 2. Okay, so I think that is what we missed. Okay, so the queue, now queue had the values like this, I mean 6 as well as this we had, and at the same time this also we have. Okay, so now 1 is associated with this 9. Okay, we check for the left and right child. There is no left and right child, so we'll simply pop that out, and now the queue looks like this. That is 6 with 0 and 7 and 2. Okay, so again the front becomes the 6 and node will be 6, and the line number is 0. So whatever the value is there at 0, we will replace with the 6 value. Okay, so now we'll check for the left and right child of the 6. Is there a left child and right child for this? There is none, so we'll not push anything into the queue. So we'll just come out, we'll just pop that out, and the queue would look like this now. That is 7 and 2. Okay, so this is what the queue looks like. So now node value is 7 and line number is 2. So whatever the value is there at 2, there is none, so we'll just associate this line number with the value 7. Again check for if there is a left and right child. There is none for this root node 7, so we just pop this out. So finally the queue becomes empty. So whenever the queue becomes empty, we'll stop it. So now whatever the values are associated with this map, we will print it in the sorted order. So by default this will be sorted by this key values. So if we try to print the map, this value, that is second value, the order with which we will be getting is 4, 8, 6, 9 and 7. Okay, this would be our bottom order traversal. This would be our bottom order traversal. If you go and see, this is what exactly the output we needed. Okay, that is what we got from this explanation. Okay, So this is the dry run, or the approach that how we should extract the bottom view of our binary tree. Okay, so let's go for the code part and execute our explanation. Okay, so yeah, let's turn into the code part. Well, now diving into the code part of bottom view. So let me import the library address required for this. So IO stream, and then the vector I would be needing, and also I would need queue. Okay, so yeah, now, and also we'll include the map to store the line number and nodes associated with that line number. Okay, finally, okay, now okay, this using namespace also will import. Okay, then create our data type, so that is struct node, and that is will be having the int val, and then the left and right pointers for left and right child respectively. Okay, so yeah, so this is our data type, and now let's write the bottom view function, so which gives us the bottom view of our given tree. So let's name this as a bottom view, and the okay, let me name go with this case. Okay, bottom view, and will the input param for this function would be the node that we will pass. Okay, first let's create one vector to store the result of our bottom view. Okay, let's name this as a result, and base condition always. Okay, if root equals to null, so what we do, we just return the result. Okay, so and let's create a map to store the line number and the nodes associated with it in the sorted order. Okay, for that we'll use map, as I already explained. Behind the scenes it will be implemented using the red black trees. Okay, kind of balanced binary search tree. Okay, so let's name this as MP. Okay, and queue to traverse our given tree. So we'll have the pair, one is the node and also the line number with which this node is associated with. Okay, and name this as a queue. Okay, and then initially what we'll do, we'll push the root. Okay, and I need this make pair function. So for that I will include the utility. Okay, like this, and make pair. So initially we'll push the root node. Okay, root node would be the node, and also the line with which it is associated is 0. Okay, fine. So now what we do, we will traverse until the queue becomes empty. So that is, while queue is not empty, we will do the traversal of our tree. So okay, so I will take the front part content of the queue, and then remove it from the queue, that is pop it, and then now the first part part in the pair is node, that is the node, and line number would be the second part of the pair, so that is it dot second. Fine. So what we do now, we will insert the node to this line number into our map, that is MP of line would be the temp to val. Okay, now what we check, if we check for its left and right child of the node, that is, if there is a left child, we will push that into our queue. Okay, with the line number decreased by 1 if it's a left child. Okay, so that is temp to left, and decrease line number by 1. Okay, and the same if right child is there for the current node, we will push the same into our queue. Okay, that is temp to right, and increment the line number by 1. Okay, for right child. Okay, so this is this is how the level order traversal of a given binary tree will happen, with just the way we want it. We are storing using a map. Okay, yeah. So now after this queue becomes empty, in map we'll have the things needed for our answer. So we'll just iterate the map. Okay, and push back the values into our result array, that is this. Okay, so as I said, the map will store in a sorted order of line number. Okay, so the result would be there in our, okay, the result will be pushed to our result array. Okay, finally we will return that array. Okay, so yeah, so this would have the required answer. And as usual, let's write a function to create a new node. Okay, that is new node, and here we'll give the integer as input value, and allocate the memory required for this node, that is temp, and this is of type struct node star, and that is use malloc, and size of struct node. Okay, yeah, so this is the how we allocate memory, and now assign the value, and left and right pointers you make them as a null. Okay, that is temp to left is null. Okay, and temp to right is null, and then return temp. So this is the simple function to create a new node. And now let's write the main function and create the tree structure we saw in the explanation part, and see if the output is matching to what we got while we were making the dry run. Okay, so let me create a root node. Okay, and root node was 1, and quickly build the tree structure I showed, that is root to left. Root to left was 2. Okay, and root to right, oh come on, root to right was 3. Okay, and then root to left is 4. Okay, then root to left to right was 5. Okay, and then root to left to right to left was 8. Okay, and then root to right was 7, and then root to right to left was 6. Then finally one more node, that is root to left to right is 9. And yeah, so let's create array and store that result of our bottom view function in this array, that is by passing the root node. So this answer array will have the answer for our bottom view. So finally what we'll do, we'll print the values at each index of that answer array. Okay, so let me write this as like bottom view. Okay, and give some spacing, and then iterate this array. Okay, and then print the value at each index, that is answer of I, and give space, and then okay, yeah, so this is it. So now let's execute this and check if the output is matching to our explanation or not. Okay, so what I just ran it. There is error. Okay, I need to give some space here. Okay, I think this should solve the issue. Yeah, so if you see, the output is 48697, which was exactly what we got in our explanation part. Okay, yeah, so this is it for this video. Stay tuned for further coming videos. Thank you.